Examine this. Why is this integral always equal to 0, or integral similar to this where the differences lie only in the limits 0 and pi over 2, or 0 and pi, 0 and 3 pi over 2, and 0 and 2 pi? Those type of limits will always zero out no matter what. And what's the reason behind that? It's to do with the u substitution and the antiderivative which comes out. How would you integrate this assuming you have 0 and pi over 2? I'll do u is equal to 2x, and then I do du is equal to 2 dx. The derivative of this, the derivative of this. From here I'm getting a du, from here I'm getting a 2 dx. You solve here for dx, push the 2 on the other side, I have a du over 2. You have limits here, x1 is equal to this and x2 is equal to that, but because of the substitution you have to create new limits, u1 and u2, and you will do it by means of this and the existing limits coming through. 0 times 2 is a 0, pi over 2 times 2 is what? It's a pi. So when you're thinking here always with the 0 and the other items, pi over 2, pi, 3 pi over 2, and 2 pi, and those type of numbers, when you do the 2 times those numbers, it always creates a value here in terms of an upper limit, which is always an x-intercept for your sine function. And that sine function comes here in terms of an antiderivative. Anyhow, I'm looking here now, 0 pi cosine u du over 2. I'll put the over 2 out. What's the antiderivative here in terms of this cosine u? It's a sine u, and you obviously have this 2, and you're going to put a pi and a 0. Put pi and a 0. You know these are your x-intercepts. You have a 0 minus 0 over 2, and it zeroes out. Hence, irregardless of just this, if you had other items here, 0 to pi, 0 to 3 pi over 2, 0 to 2 pi over 2, by virtue of the items which would end up here and this antiderivative, it will always be a presentation 0 minus 0 over a item here, and it always zeroes out.